Hey there, statistics and pre-calculus, reviewing location in a normal distribution. So where things are in a normal distribution, a bell curve, it's all good. If you remember, you have most of your data within one standard deviation of the mean. Your percentages here are 68% within one standard deviation. That's 34% here, 34% here. Another 13.5% in each side around, 13.5%, 13.5% between 1 and 2 standard deviations away from the mean, and about 2.5% more than 2 standard deviations away from the mean in either direction, 2.5%. Good. So that's your approximate numbers, and you can use those if you're looking for values in between. So if you're looking for values that are right on the standard deviation. If your numbers are off of that, however, you need to use your calculator to come up with these different pieces. If you're given a range of numbers, find what percent fall there. You use the Normal Cumulative Distribution Function, or the Normal CDF. You put in the lower and upper bounds and the mean and standard deviation, and you get it. If, on the other hand, you're given the percentile and you want to find out what the value is of that percentile, you do the opposite. You do the inverse normal. Again, under statistics distributions, and you enter the percentile as a decimal and the mean and standard deviation, and you get some nice numbers. So, for instance, if you said how much of the data is between negative infinity and 1 standard deviation above the mean, you get 84%, which matches what you know, 50% below the mean and another 34% in that chunk. Likewise, the 16th percentile, you get about 1 standard deviation below the mean. So again, 50% minus 34%, and you're good there. So, an example, suppose the heights in inches of women aged 20 to 29 in the US are normally distributed with means of 64.1 and a standard deviation of 2.75. You don't have to suppose, that's pretty accurate data. So we're looking at 64.1 in the middle. I'm just going to go 64.1 plus 1 standard deviation is going to be 66.85. Plus another standard deviation is going to be 69.6, and so on. And if you go down the other way, so minus 361.35 and minus another 2.75, that would be 58.6. So we got those numbers. So you're looking at where these are. So the first question is saying the percent of women who are no more than 65 inches tall. So 65 inches is going to be about here. And so we're going to talk about more than 50%. You expect more than 50% of the women, but not a whole lot more than 50%. So 65 inches tall, 5'5". So quick look on the calculator. Menu, statistics, distributions, Normal CDF, and we are looking for less than 65 inches tall. So you could use negative infinity, you could use 0 because it's not going to be less than that, up to 65, and the mean was 64.1 and the standard deviation was 2.75. We run it and we get the answer 0.628. So that's about 63% of women are going to have 63% of women. It didn't copy. 63%. There's our copy. 63%. Oh, good heavens. I'm not going to copy anymore. I'm sorry for the delay. Did I lock something up? Don't know. So, about 63%, which matches what you said that it should be. Matches what we looked at it when we said it's going to be more than 50%, but not crazy more than 50%. So the second question, what about women who are between 60 and 63 inches tall? You would do the same thing. You would do a normal CDF, menu, statistics, distributions, Normal CDF, choice 2, And in this case, 60 to 63, so that's 60 to 63 with a mean of 64.1 and a standard deviation of 2.75. And we get that about 27% of women, 28%, are in that range. Let's just make sure that that makes sense. 60 to 63 would be about here. 60, as you know, 60 would be about here. 63 would be about here. Yes, that makes sense. 27%. 28%, 27.6%. If you're going the other way, the next question is, what's the probability, or given the 70th percentile, how tall is somebody at the 70th percentile? I'm going to go back and make sure we've got our numbers. 64.1. 70th percentile is higher than this, so I'm just going to write 66.85, which is the next one up. And we know that 70th percentile is going to be in here someplace because of this 34%. So 70th percent is going to be there. So between 64.1 and 66.85, we know that. Going into it, can anticipate that. Let's run the numbers. In this case, you know the percentile, you're going for an inverse normal. Menu statistics distributions, and in this case, the inverse normal. Choice number 3. 70th percentile is 0.70 for the area. The mean, 64.1, the standard deviation, 2.75, and here we go. It tells us that at the 70th percentile, that person is 65.5 inches tall, 5'5.5". So 65.5 inches, which makes sense. It's right smack where we think it's going to be, and so 70% are down here. There you go. The quick summary again. If you're looking to do, if you've given a range and you want to find what percent, you use the normal CDF. If you know the percent and you want to find the range or the value, you use the inverse normal. All good. Enjoy.